Did you notice that ice floats in water? Have you ever wondered why ice can float while other solids usually sink in water? To explain this phenomenon, first of all, we have to be familiar with the concept of density. Density can be determined by dividing mass with volume. From the formula, we can see that density is inversely proportional to volume. That means if volume is reduced, the density will increase and vice versa. Now, most solids has close-packed arrangement. Because their molecules are arranged very close to each other, they will occupy less volume. Less volume will contribute to high density. Since most solids have higher density than water, therefore they will usually sink in water. However, the phenomenon of ice floats in water suggests that ice have lower density than water. We have learned earlier that because of the presence of hydrogen bonded to oxygen in water, water molecules can form hydrogen bond with each other. It can form up to 4 hydrogen bond per molecule. This 4 hydrogen bond will assume tetrahedral molecular shape for each water molecule. This tetrahedral network will lead to open hexagonal structure. This is how tetrahedral hydrogen bond network among H2O looks like. From the side angle, you can see that it forms hexagonal shape. That is why an ice flake have hexagonal shape. This open hexagonal structure consumes a lot of space, which means high volume occupancy. Since volume is high, the density will be low, which explains why ice is less dense than water. Liquid water, however, have higher kinetic energy compared to solid water, which is ice. Because of this higher kinetic energy, the water molecule can overcome some of the hydrogen bond. Since there are less than 4 hydrogen bonds that can be formed now, the tetrahedral network will be disrupted, hence collapsing the open hexagonal structure. The liquid water will now assume the V-shaped molecular geometry. This V-shaped structure allows water molecules to slide over one another, causing them to be much closer to each other. Therefore, less space is needed and less volume will be occupied. Since volume is low, the density will be high, which explains why liquid water is more dense than ice.